Okay, to find the exact value of cos pi on 5 and cos 3 pi on 5, I'm going to using the fifth root of -1. So I let fifth root of -1 be z. Therefore, we have z to the power 5 would be equals to -1. Then I have said 5 plus 1 equal to 0. So I'm going to solve this equation two different ways. One is using complex numbers, one is using polynomials. And to using the complex number to finding the fifth root of -1, I'm going to using the de Moivre theorem by these formulas. So if I have z to the power of n equals to a complex number using the mod arg form r6 theta. By de Moivre theorem, I can have z is equals to r to the power of 1 over n and 6 2k pi plus theta over n, where the k can be 0, 1, 2, all the way to n minus 1, or k can equal to 0, 1, -1, 2, -2, etc. So I'm using this formula to solve this equation by first let -1 into mod arg form with modulus is 1 and the angle is modulus 1. Angle is pi. Argument is pi. So then z is equals to 1 to the power 1/5, still 1, and 6 2k pi plus pi over 5, where the k is 0, plus minus 1, plus minus 2. So I have z equals to 6 pi on 5, 6 negative pi on 5, 6 pi, 6 3 pi on 5, and 6 negative 3 pi on 5 with different value of k. I get these 5 different roots. And this answer is, we have sort of have, as you can see, pi on 5, that's what we need, and we have 3 pi on 5. The problem is we have a 6 here. It's not a cos, it's a 6. So how are we able to change the 6 into cos? We have these formulas. Let's write this formula down, which is, we have z plus z and -1 is equals to 2 cos theta. This is the formula we have here. So I'm going to use this formula to change the 6 into cos by z plus z and -1 is equals to 2 cos pi on 5. And also I have z plus z -1 equal to 2 cos 3 pi on 5. To getting these two sentences, I was using this set and this set together to get this sentence. And also using this set and this set together to get this sentence. So this sentence allow me to getting cos instead of cis. So how do I find the value of cos, exact value of cos pi on 5 and cos 3 pi on 5? I'm going to do the equation by the second way, which is polynomial ways. So, and equate the result to these two sentences here. So first I have this sentence. So I'm going to find another result for z plus z -1 by using polynomial ways for this equation here. Okay, so polynomial ways. Z5 plus 1 equal to 0. I'm going to factorize this into z plus 1 and z power of 4 minus z power of 3 plus z power of 2 minus z power of 1 plus 1 equal to 0. And then I'm going to have z plus 1, and I'm taking z square here, and I have z square minus z plus 1 minus z to the power of negative 1 plus z to the power of negative 2 equal to 0. So to doing this, take z square out, they allow me to having z square plus z negative 2, and also have z and z negative 1, because this give me a conjugate pair, as I mentioned before here. I need to finding what's z plus z negative 1 in a different way, and we can equate the result to getting the value of cos pi on 5 and cos 3 pi on 5. So here, after taking z square outside, I can see I already made z plus z negative 1, but still have a bit trouble with z square plus z negative 2. So I'm going to continue to changing the z square plus z negative 2 into z plus z negative 1 whole square. So I'm going to continue my sentence. I put z square outside and z plus 1 here, and then we focus on the second part here. So with z squared plus z negative 2, I can change to z plus z negative 1 all square and minus 2. So this sentence here is made by this term and this term. Give me all the whole sentence here. And then I'm continue minus with z plus z negative 1. That's a good term here. I need that, and plus 1. Okay. And then continue. I'm going to copy these two here, and I have z plus z negative 1 square minus z plus z negative 1 minus 1 equal to 0. So this is a very important equation I made in here. This is the equation in quadratic about z plus z negative 1. If I taking z plus z negative 1 as whole big terms, like a big X, and you can see I made a quadratic about that. And if I let z plus z negative 1 as X, then I can say using quadratic formula z plus z negative 1 is equals to quadratic formula negative b, which is 1, plus minus square root of b squared, which is 1, minus 4 times a, which is 1, c is negative 1, 4ac, over 2a, a is 1, so which gives me 1 plus minus square root of 5 over 2. That's z plus z to the power negative 1. But as you still remember, from the top right corner, we have z plus z negative 1 is equals to 2 cos pi on 5 and 2 cos 3 pi on 5. So then I can equate this result with 2 cos pi on 5 is equals to 1 plus square root of 5 over 2, and 2 cos 3 pi on 5 is equals to 1 minus square root of 5 over 2. And I equate cos pi on 5 to 1 plus square root of 5, because pi on 5 is in the first quadrant, so 1 plus square root of 5 is positive. So then this matches cos pi on 5 is positive values. And I also equate the 2 cos 3 pi on 5 is into 1 minus square root of 5 because 3 pi on 5 is second quadrant and cos 3 pi on 5 is negative, and the 1 minus square root of 5 is negative. So I get 2 cos 3 pi on 5 equal to 1 minus root 5 over 2. So I equate them. Then for the final result, I get cos pi on 5 is equals to 1 plus root 5 on 4. And the cos 3 pi on 5 is equals to 1 minus square root 5 on 4. That's how I get exact values for these two cos values by using two different ways to solve the equation of set 5 plus 1 equal to 0 by using complex numbers and the polynomials. Then I get results.